The SIRE project, Network Engineering System, is an advanced system that Sirti, a leading Italian telecommunications company, has developed for the automation of procedures for the engineering of telecommunications networks in urban areas. The need to automate procedures that are at the present carried out in the traditional way arises from the need to eliminate, or at least reduce, all the repetitive and computational work phases which seriously hold up the overall development of the system being engineered. The objectives of the project as a whole cover all aspects of the design and construction of a network that can in some way be automated. The basic starting data are made up of information taken from topographical maps of the area covered by the network. These data are later integrated with specific data regarding the user's needs.
All the information gathered is distributed on different memory levels on the basis of the classification given below. Geometry of the land base, toponyms, street numbers, data from the ecographical survey. The SIRE system either receives the basic cartographic data already in digitalized form or provides the operator with the functions needed to digitalize it. The man-machine dialogue is carried out chiefly by means of tutorial menus for handling the graphic part and alphanumeric menus for the non-graphic part.
A work session starts with the procedure displayed on the screen, which involves identification of the exchange area and identification of the cable operation area.
On the monitor, the main application menu then appears, offering a choice between different options. At this point, the engineer selects the option 8 from the main menu to call back the topographical maps. The geographical data displayed are loaded onto a file called Geographical Index, where the maps are assembled on the basis of their coordinates. The engineer loads the maps regarding the new portion of territory, selects the option Addition on the menu, and then keys the name of the map. The system will then search for the map in the file and allocate it to its exact position. At this point, the engineer selects option 2 on the menu and moves on to the network engineering. The system loads the graphic file of the area being examined, activates the menu, and loads the land maps and all the functions involved in the option selected. The engineering menu is linked to a whole series of submenus which can be subsequently called in order to define all the network elements and execute other related procedures.
The engineer can display the type of representation of the planned network on the basis of information needed for subsequent development. This is done by calling the network pattern menu from the engineering menu.
The level connected to the presentation required are activated on the basis of the network pattern selected. Selection of the option network displays the engineering status of the cable area in question, showing the development of the main network except the terminal part of the RL0404 frame.
The main network is shown in pink and the terminal in red. If he wishes to complete the engineering of the terminal network, the operator displays the frame area by means of the zoom.
The example shows the connection of number 31 via Piemonte to the network that needs to be completed by the addition of 23 twin cables. By means of the engineering menu, the engineer calls the termination menu and then selects the type of termination he wishes to install, and then choosing the distribution point and defining its characteristics. Terminal numbering, location, capacity, installation, cross-connection box, terminal strip. Once the form has been compiled through a sequence of operations guided by the system, the distribution point symbol and the associated text is positioned. The operator then passes to the cable menu and selects the symbol related to the type of installation, example, overhead cable, and thus gains access to the information regarding the section in question. The section attributes form is then filled in, giving all the technical information regarding the cable section involved. In order to take into account any kind of possible lack of homogeneity within the section concerned, different types of cable installation, different widths or depths of the trenches and so on, the procedure includes a segment-by-segment analysis of the section. The information form for the segment appears and is filled in if the cable, as in our case, is laid on a wall, fixing in the attribute ID, that is the first segment. The next step is tracing of the first segment. The system automatically calculates the length of the segment. At this point, the engineer can either accept the data proposed or modify it.
The length is then stored in the memory of the data bank together with information regarding the section and the particular segment in question.
The next step is positioning the text.
The same procedures are followed for the representation of the second segment, which is to be laid in a trench.
In the event of there being several segments within one section, the system will recalculate the total length of the section, modify the data previously stored in the data bank, and vary the text on the drawing.
Following the same procedure by means of the options on the menu, the tracing of the network will be completed.
The system is able to associate network elements with drawings containing detailed information that cannot be found on the blueprint drawings. Use is made of this possibility in the presentation of schematic frame drawings of pipelines and pressure systems. By means of menus and system functions, the engineer is able to view previously constructed schematic drawings.
One of the engineering procedures offered by the system is the calculation of the electrical parameters of any of the point-to-point connections in the network.
In order to activate this procedure, a phase subsequent to the network definition defines the data regarding the occupation of the sectors of each cable and the link between each element and the one immediately upstream of it. The system identifies all the network elements which combine to make up the connection in question, reads all the information in the data bank, type of cable, conductor section, etc., needed to calculate the resistance and attenuation at two different frequencies, 800, 1600 hertz. The result of the above calculation is then displayed on the screen.
Following the network engineering carried out on a graphic workstation, the next step is the development of the accounting phase. This phase uses an alphanumeric terminal showing the system elements characterized during the design phase, sections, joints, etc., for an evaluation of the network using specific items of the specifications plant unit.
The accounting phase handles all the installation activities and the materials to be used in the construction of the planned network. The calculations are made on the basis of the data memorized during the design phase, plus those added during the accounting phase.
At the end of the engineering phase and accounting phase, the printout is arranged. Finally, the engineer responsible provides for storing the work carried out through the procedures showed in this movie.